Hey, hello ib3 standard level and higher level students. Today I'm going to give you solutions for November 2018 session. I don't have calculator, so I'm not going to calculate all from the beginning to the end. I will focus on the method. Your task now is to open November 2018 session. Okay, this is this paper. Okay, and solve all exercises. Yes, remember that you have 15 marks, so this is 1 hour and 15 minutes. Okay, so let's say you have 1 hour, and after 1 hour, please stop your calculations, turn it video, and I'm going to present solutions for all exercises in 1 hour. Okay, so start. Okay, so now 60 minutes later. Okay, 60 minutes later. Okay, so let's focus on the exercise. In exercise number 1, we have thrust engine. Direction of spacecraft motion is to the right. Direction of movement of ions ejected is to the left. Okay, we have information, mass of ions ejected in 1 second, speed, and total the mass of the spacecraft, which is fuel. And first you have to find acceleration of the spacecraft. I'm going to do this in this form. Okay, initial acceleration of the spacecraft. So what is initial acceleration of the spacecraft? To find acceleration, you have to know a force. Is it clear? So force, which is mass times acceleration. To find force, you can use the law of conservation of linear momentum, that change of momentum of the ions in time. So how to do this? Delta P, we have speed and we have mass of ejected ions in 1 second. So in 1 second we have 6.6 times 10 to the power of minus 6 of kilograms of ions which are ejected, with speed of 5.2 times 10 to the power of 4. Multiply this, so 6.6 times 5.2 gives 34.3. So this is 34.3 times 10 to the power of minus 2. So 3.43 times 10 to the power of minus 1 of newtons. Okay, very small force, but mass of ejected ions is very small. So acceleration is this force divided by total mass of the spacecraft. So 3.43 times 10 to the power of minus 1 divided by mass, which is 740, which results in 0.343 divided by 740 gives 4.6 times 10 to the power of minus 4 meters per second squared. Okay, not complicated. Second, an initial mass of 60 kilograms of fuel is in the spacecraft for a journey to a planet. Half of the fuel will be required to slow down the spacecraft before arrival to the destination planet. Estimate the maximum speed of the spacecraft. So we know that half of this fuel is needed to accelerate and half of this fuel is needed to slow down. So you can write that mass needed to accelerate. So let's copy this. Mass needed to accelerate is 30 kilograms. Okay, so mass of the fuel needed to accelerate is 30 kilograms. Okay, so the question is about the maximum speed. So let's look. We know that in 1 second, amount of fuel which is released is 6.6 times 10 to the power of 6. So we can calculate number of seconds, the length of the journey, if we know that 30 kilograms of fuel is needed to accelerate this. Simple proportion, find the length of the journey, this is time of course, as this times this over this times this, which is 30 divided by 6.6, which is 4.55 times 10 to the power of this is 10 to the power of 6 of seconds. Okay, and we know we have to find maximum speed. There is an equation that v squared is u squared plus 2as. No, this is not a good equation. Maximum speed. So we can use change of velocity as the product of acceleration and time. Acceleration was calculated in previous point, time of the journey in this point, so by multiplying we can find maximum speed 4.6 times 4.55, which gives 20.9, so 2.09, so 2.1 approximately, 2.1 times 10 to the power of 2 times 10 to the power of 3 meters per second. This is maximum speed gained by the spacecraft. Outline why scientists sometimes use estimates to making calculations. Because to make calculations easier, just this. Okay, in practice the ions leave the spacecraft a range of angles. Outline why the ions are likely to spread out. Okay, let's look. Ions are charged particles, yes? Like positively charged particles. So they are repelled by electrostatic forces. Okay, so they escape not in straight line, but due to the electrostatic forces are spread out. Explain what effect, if any, this spreading of the ions has on the acceleration of the spacecraft. Okay, so the overall vector, this thrust force or force will be shorter because each ion has a component of force in horizontal direction, which is less than overall force acting on the ion. So if overall force will be smaller, then acceleration of course will be smaller. And D. On arrival at the planet, the spacecraft goes into orbit as it comes into the gravitational field of the planet. Outline what is meant by the gravitational field strength at the point. Okay, so gravitational field strength is gravitational force acting on unit point test mass. Newton's law of gravitation applies to point masses. Suggests why the law can be applied to the satellite orbiting a spherical planet of uniform density. Because if you have a planet of uniform density, then gravitational field created by this planet is exactly the same as gravitational field created by the point mass of mass the same as this planet. Okay? Okay, so exercise number 2, electricity. Let me change slide. Okay, so electricity. We have a lightning system, consists 2 long metal rods, potential difference maintained between them, identical lamps can be connected between the rods, etc, etc. And we have data which are given. I'm going to copy this data. Okay, and first question is each rod is to have a resistance not greater than 0.10 ohms. Calculate in meters the minimum radius of each of the rod. Give your answer to appropriate number of significant figures. Okay, so we have first question maybe here. Okay, so what do we have? The lamp specification is given 24 volts 5 watts, power supply has 24 volts, and power supply maximum current is 8 amperes. Length of each rod is given, and each we have the resistivity, and we have to calculate the minimum radius of each rod. So basically the question is about resistance. So let's look. We have current and voltage of the power supply, so we can calculate what can be a power of this power supply. Yes, so power of power supply is V times I, so 24 times 8, which gives 24 times 8 gives us 192 of watts. Okay, and we know that lamp has a power of 5 watts. So how many watts can be dissipated in the rods? In 2 rods, the power which can be dissipated is 187 of watts. Is it clear? If 187 in 2 rods, and rods are connected in series with the lamp, then each rod, okay, has a power of 93.5 of watts. Is it clear? Okay, so we know that give your answer, calculate in meters the minimum radius of each. Oh, wow, sorry, you don't need to calculate this by power, sorry, because the resistance is given, length is given, resistivity is given. It will be needed in next point. In the case of A, you can use equation for resistivity. Resistivity for resistance, sorry. Resistance is resistivity times length over cross-sectional area, and resistance is given, resistivity is given, length is given. By using this equation you can calculate surface area, and of course area is pi r squared. So you can calculate where r is a radius, you can calculate this radius by using this equation. So radius of each rod will be cross-sectional area obtained in previous calculations divided by pi and square root of this. So, okay. B. Calculate the maximum number of lamps that can be connected between the rods. Neglect the resistance of the rods. So now we have to neglect the resistance of the rods. Okay. And we have to calculate number of lamps. So let's look. Power supply can deliver to us 192 watts. Yes? Each lamp takes 5 watts. So how many lamps can be connected? 192 divided by 5. Power is independent on the type of connection, so you can use this method. Okay, of course, number of lamps is integer, so you have to round it down. So number of lamps which can be connected is 38. Okay? And third, one advantage of this system is that if one lamp fails, the other lamps in the circuit remain lit. Outline one other electrical advantage of this system compared to one in which the lamps are connected in series. So, advantage of parallel connection. Okay, each lamp has the same voltage. It's huge advantage. We can use identical lamps, each has the same voltage and each has the same current, and just this. Okay. So we finished exercise. So now exercise number 3. A chicken's egg of mass 58 grams dropped into grass from height of 1.1 meter. The egg comes to rest in time of 55 milliseconds. Assume that A resistance is negligible and the egg does not bounce or break. Determine the magnitude of the average decelerating force that the ground exerts on the egg. Okay, classical exercise with momentum. Okay, exercise number 3. Change the slide. Okay, so magnitude average decelerating force. So let's look. Force is change of momentum over time. Yes? Time is given 55 milliseconds. Mass is given, and we have to find the speed when egg falls from height of 1.1 meter. A resistance is neglected. So you can use typically uniformly accelerated motion when distance is given and acceleration is given. Acceleration is g, so 9.81. Distance traveled is given as 1.1 of meters, and the question is about speed of collision. So equation linking this is v squared equals u squared plus 2ad. So by using this you can calculate velocity. And now, if you know velocity, you can use this equation, mass is given, times is given, and change of velocity is this velocity because during collision it decelerates from this velocity to 0. So this is average decelerating force. Second, explain why the egg is likely to break when dropped onto concrete from the same height. Okay, in the case of concrete, of course, the time of collision is reduced. Okay, so time of collision is shorter. If time of collision is shorter, then in this equation we have the same numerator but smaller denominator, which means that force is much more bigger. If time of collision is, let's say, 10 times shorter, then force acting on the egg during deceleration is 10 times bigger. So this is why grass is better for egg than concrete. In the case of grass, we have longer time of collision. In the case of concrete, we have shorter time of collision, so bigger force. Next, this is the end. Exercise number 4, about standing wave. A pipe is open at both ends. First harmonic standing wave is set up in the pipe. The diagram shows the variation of displacement of air molecules in the pipe with distance along the pipe at time t equals 0. Frequency of first harmonic is f. Let me copy this picture. And now air molecule is situated at point x in the pipe at t equals 0. Describe the motion of this air molecule during one complete cycle of the standing wave as beginning from t equals to 0. So let's look. This is an air molecule, so it is a longitudinal wave. In the case of longitudinal wave, this air molecule at x travels from left to right. So again, air molecule is situated at x at t equals to 0. Describe the motion of the air molecule during one complete cycle of the standing wave beginning at from t equals to 0. And t equals to 0 is here. So let's look. What is the... Okay, why? Because the position of displacement is negative. Okay, so in one complete cycle, x will be displaced from left to right and from right to left. Okay, remember this is longitudinal wave, so it travels along, the vibrations are along the pipe. This is only representation of displacement. This is not the real displacement of the x. Second, the speed of sound in longitudinal wave is given by equation. Rho is density and k is a constant. Student measures f to be 120 Hz when the length of the pipe is 1.4 meters. The density of air is given. Determine the value for k. Okay. So now we have to find c by using this data and substitute the equation. So what is c? Speed of the wave. What is speed of the wave, or what is the length of the speed of the wave? Let's look. To find speed of the wave, we have to know speed, or c, in this case is c. We have to know frequency and lambda. Frequency is given directly, but what with lambda? Lambda is related with length of the pipe. Okay, length of the pipe multiplied times 2 is lambda. Okay, so length of the pipe is given, frequency is given, it's easy to find c. And now if c is given, we can calculate k because rho is also given. Okay, so also not difficult exercise. And one more. A transmitter of electromagnetic waves is next to a long straight vertical wall that acts as plane mirror to the waves. An observer on board detects the waves both directly and as an image from the other side of the wall. The diagram shows one ray from the transmitter reflected the wall at the position of the image. Okay, so this I'm going to copy and paste in new slide. Okay, and demonstrate using a second ray that the image appears to come from the position indicated, and outline why the observer detects a series of increases and decreases in the intensity of the received signal as the body moves along XY line. Okay, so this and here. Okay, so we have to do another ray which shows that the position of the image. Okay, so using another any ray. Remember that must be law of reflection. Position of the image should be the same. Okay, elongations of the rays should be crossed at the same position at the same point. Just this. And second, it was 1, and now the second. Outline why the observer detects a series of increases and decreases in the intensity of the received signal as the body moves along the line X and Y. And what is the phenomenon? Of course, the interference, yes? So sometimes there is a constructive interference, sometimes there is a destructive interference, just this. Okay, exercise number 5. The diagram shows position of principal lines of visible light spectrum of hydrogen, atomic hydrogen, and some energy levels. Determine the energy of photon of blue light, which has 435 nanometers of length. So let me copy this and new slide. Okay, so energy of photon, energy is h times f. Okay, and f is speed of light divided by lambda. So 6.63 times 10 to the power of minus 34. Speed of light is 3 times 10 to the power of 8 divided by lambda, which is 435. Remember that nano means 10 to the power of minus 9 of meters. Put to your calculator and calculate it. And identify which an arrow labeled B on the diagram the transition in the hydrogen spectrum that gives rise of the photon with the energy in A. So in this case you have to find this number as a difference between two of these numbers. I don't know what is the answer. If difference is this, then you have to create arrow from this to this, because emission means that energy level decreases. If if this number is difference between this and this, then you have to create arrow between upper and lower. Upper and lower because we have emission of photon. Explain your answer to B. So this is something what I said. Okay, exercise number 6. The ratio distance of Mars from the Sun to distance Earth from the Sun is 1.5. Show that the intensity of solar radiation at the orbit of Mars is about 600 watts per square meter. Okay, so you have to use here the inverse square law of radiation, and you have to remember solar constant. Solar constant is given in your data booklet. So solar constant is amount of radiation received by 1 square meter above Earth's atmosphere at the position of the Earth. So solar constant for the Earth is 1.36 times 10 to the power of 3 watts per square meter. Okay, we have to find the same for Mars. Okay, and we know that distance of Mars to the Sun divided by distance Earth to the Sun is 1.5. Okay, so this is our data. Okay, so Mars is 1.5 times further. Okay, so remember that intensity is proportional to 1 over distance squared. So in this case, 1 over distance squared will be 1 over 1.5 squared, so 1 over 2.25, which is equal 1 over 2.25 is 0.44. Okay, 0.44 multiplied by 1.36 times 10 to the power of 3 gives us probably something we're looking for. So this is 598, approximately 600 watts per square meter, and this is the answer. Determine in kelvins the mean surface temperature of Mars. Assume that Mars acts on a black body. Okay, so do you remember intensity was this multiplied times temperature to the power of 4. So we know intensity, we know constant. This constant is here. This is Stefan Boltzmann constant. So you can calculate the temperature. Of course, equation I've used is in your data booklet on topic number 8 here. Okay, you have for power. Intensity is power divided by A, so A is crossed. Black body has E equals to 1, so we have sigma T to the power of 4. Okay, and one more. The atmosphere of Mars is composed mainly of carbon dioxide and has a pressure less than 1% of one of the Earth. Outline why the greenhouse effect is not significant on Mars. Okay, small pressure means that we have small amount of mass of the atmosphere, which means that there is a less number of very small number of carbon dioxide of molecules in the Mars atmosphere, so we have less or very small amount of greenhouse gas. So this is why. Okay, and one more. Liquid oxygen, as its boiling point, is stored in an insulated tank. Gaseous oxygen is produced from the tank when required using an electric heater placed in the liquid. Following data available, we have mass of 1 mole of oxygen, a specific latent heat of vaporization. Distinguish between the internal energy of oxygen at the boiling point when it is in its liquid phase and when it is in the gas phase. So internal energy is the sum of potential and kinetic energies of all particles. Kinetic energy is the same because at the boiling point or liquid or gas phase have the same temperature, so kinetic energy is the same, but there is a different potential energy. In the case of boiling, we have bigger distance between molecules, so energy is bigger, so internal energy of the gas is bigger. Okay? An oxygen flow rate of 0.25 moles per second is needed. Calculate in kilowatts the heater power required. So here we have what do we have? Again, gaseous oxygen is produced from the tank when required using an electrical heater placed in the liquid, and we have 1 mole has a mass of 32 grams. And specific latent heat of vaporization is 2.1 times 10 to the power of 5. And the heater power. Okay, so let's look. We need 0.25 moles per second. 0.25 moles means that we have 8 grams. Okay, 1 mole has 32 grams. And we need 0.25 moles per second. So we need 8 grams of this oxygen, and specific latent heat of vaporization is given, and we have to find the power. So power is energy over time, so mass specific latent heat of vaporization divided by time. This is given 8 grams times specific latent heat of vaporization is 2.1 times 10 to the power of 5. And finally, remember to convert it into kilowatts, not in watts but in kilowatts. And next one, calculate the volume of the oxygen produced in 1 second when it's allowed to expand to a pressure of 0.11 megapascals and to reach a temperature of 260 kelvins. So PV equals nRT. Okay, in 1 second we have 0.25 moles. This is constant, this is given, this is also given. So there is only one unknown volume. So by using this equation, and state one assumption of the kinetic model of an ideal gas that does not apply to oxygen. Example, oxygen is not a point mass, just this. Okay? Oof, I hope you did this correctly. Thank you for watching. Any comments, write to me in Google Classroom or on my YouTube. Okay, and learn physics, stay at home, and see you next time. Bye.